What if I told you that everything you have ever seen, every person, every planet, every star, fits inside a cosmic bubble so vast your brain literally cannot picture it? Today, we begin a journey to understand the true size of the universe, step by mind-bending step. Let's start where you are right now. You are standing on Earth, a planet about 12,742 kilometers across. Sounds huge, right? But Earth is just one world orbiting a medium-sized star, the Sun. And the Sun is so big that over 1 million Earths could fit inside it. But even the Sun is tiny on the cosmic stage. Our solar system stretches billions of kilometers into space, far beyond Pluto, into a vast cloud of icy objects. If Earth were the size of a grain of sand, the solar system would still span an entire city. And here's the wild part. Everything we call home, every planet, asteroid, and comet, is just the first microscopic step in measuring the universe. In this series, we're going to zoom out, again and again, until distance itself starts to lose meaning. This is not just about size. It's about perspective. And by the end, you may never look at the night sky the same way again. Now that we understand Earth is tiny compared to the Sun, let's zoom out to see the full scale of our solar system. Light travels at nearly 300,000 kilometers per second. It takes sunlight about 8 minutes to reach Earth. That sounds fast, but reaching Neptune, the outer major planet, takes over 4 hours. Already, we are dealing with distances that stretch human imagination. If the Sun were the size of a basketball, Earth would be a small peppercorn about 26 meters away. Jupiter, the giant of our planetary family, would be over 130 meters away. And Neptune would sit nearly a full kilometer from our basketball sun. But even that doesn't capture the real boundary. Far beyond the planets lies the Oort cloud, a vast spherical halo of icy objects. This distant region marks the outer edge of the Sun's gravitational influence. If scaled down, the solar system would span an entire continent. Everything you have ever known exists inside this single stellar neighborhood, a tiny island in an ocean we have barely begun to measure. To measure the universe, astronomers needed a new ruler, and they found one in light itself. A light year is the distance light travels in 1 year, about 9.46 trillion kilometers. This unit exists because ordinary measurements become meaningless beyond our solar system. The closest star system to Earth is over 4 light years away. That means the light reaching your eyes tonight began its journey before many modern technologies even existed. Imagine shrinking Earth to the size of a marble. At that scale, the nearest star would still be thousands of kilometers away. Space is not just big, it is overwhelmingly empty. Light becomes our time machine. When we look at distant stars, we are seeing history. The farther we look, the further back in time we peer. Distance and time are woven together across cosmic space. Understanding the size of the universe begins with understanding how far light can travel and how long the universe has allowed it to move. Our solar system is not alone. It orbits within a vast spiral structure of stars, gas, and dust, our galaxy. The Milky Way contains hundreds of billions of stars. If you could travel at the speed of light, crossing the galaxy from one side to the other would take about 100,000 years. Picture the galaxy as a giant rotating city of stars. Our solar system sits in a quiet suburban region, far from the crowded central core. From our position, we see the galaxy as a glowing band stretching across the night sky. If the solar system were the size of a coin, the Milky Way would be the size of a continent. Every star you see at night belongs to this single structure. And here's a staggering thought. Our galaxy is just one among countless others. We are not only part of a solar system, we are residents of a cosmic metropolis. Galaxies come in many shapes and sizes, but even the smallest dwarf galaxies contain millions of stars. Large galaxies can hold trillions. The nearest major galaxy to us is on a collision course with our own, but it is so far away that the event will not begin for billions of years. The distance between galaxies is measured in millions of light years. If the Milky Way were reduced to the size of a dinner plate, the nearest comparable galaxy would be another plate sitting several meters away. Between them, almost complete emptiness. Yet gravity connects these massive structures across unimaginable distances. Galaxies interact, merge, and reshape one another over cosmic time. To grasp the size of the universe, we must stop thinking of stars as the main building blocks. Instead, galaxies are the true fundamental units, immense star systems drifting through the cosmic dark. Galaxies rarely travel alone. They gather into enormous families called galaxy clusters. A single cluster can contain hundreds or even thousands of galaxies bound together by gravity. The space between them is filled with hot plasma and invisible dark matter that outweighs everything we can see. If galaxies were cities, clusters would be nations. The distances within a cluster are measured in millions of light years, yet gravity keeps them connected. These clusters are among the largest structures held together by gravity. Their sheer mass bends light from objects behind them, acting like natural cosmic lenses that magnify the distant universe. By studying clusters, astronomers discovered that visible matter makes up only a small fraction of cosmic mass. The rest is hidden, shaping the architecture of the universe on the grandest scales. Clusters themselves are not randomly scattered. They form part of even larger structures called superclusters. These immense regions stretch hundreds of millions of light years across. But the universe is not evenly filled. Instead, galaxies trace gigantic filaments that weave together like a cosmic web. Between these filaments lie vast voids, regions so empty they contain almost no galaxies at all. The structure resembles foam or a three-dimensional network of glowing threads. If galaxy clusters were grains of sand, superclusters would be entire coastlines. The observable universe reveals patterns on scales so large they challenge the idea of structure itself. This cosmic web is the scaffolding of the universe. It is shaped by gravity, dark matter, and the expansion of space over billions of years. There is a limit to how far we can see, not because of technology, but because of time. The observable universe includes everything whose light has had time to reach us since the beginning of cosmic expansion. Its diameter is about 93 billion light-years. That number seems impossible. The universe is only about 13.8 billion years old, yet space itself has expanded, stretching distances beyond what light alone could traverse. Imagine a sphere centered on Earth, containing every galaxy we can observe. Beyond that sphere may be more universe, perhaps infinitely more, but we cannot see it. The observable universe is not the whole universe. It is simply the portion accessible to us, bounded by the speed of light and cosmic history. The universe is not static. It is expanding in all directions. Galaxies are not flying through space away from a central point. Instead, space itself is stretching. The farther a galaxy is from us, the faster it appears to recede. This expansion began with an extremely hot, dense early state and continues today. On the largest scales, distances between galaxy clusters grow over time. Imagine dots on the surface of an inflating balloon. Each dot sees every other moving away, even though none is at the center. This expansion shapes everything about cosmic size. The universe today is far larger than it was when the first light began its journey. As we measure larger and larger scales, something unusual happens. Space and time stop behaving like everyday experience. Looking deeper into space means looking further into the past. We observe galaxies as they were billions of years ago. Some of the light reaching us began its journey before Earth existed. At extreme distances, we approach the earliest visible radiation, the afterglow of the young universe. Beyond that point, light cannot yet reach us. The edge of the observable universe is not a physical wall. It is a boundary of information defined by time, expansion, and the limits of light. Understanding cosmic size ultimately means understanding cosmic history. Everything we have measured describes only the observable portion of reality. But what lies beyond? One possibility is that the universe extends forever. If true, space has no edge and no final boundary. Another possibility is that the universe curves back on itself in a shape too large for us to detect. Current observations suggest the universe is extremely close to geometrically flat on large scales. But flat does not mean small. It could still be infinite. The true size of the universe may be beyond measurement. We can observe patterns, expansion, and structure, yet the full extent may remain permanently unknown. The greatest scale of all may not be a number, but a question. We began with Earth, a small world orbiting an ordinary star. We zoomed outward through the solar system, the galaxy, clusters, superclusters, and finally the observable universe. Each step revealed a deeper truth. Size in the cosmos is not just large, it is beyond ordinary comprehension. Distances stretch billions of light years. Structures span scales that dwarf imagination. And yet, within this immense universe, conscious observers exist who can measure, question, and understand it. The ability to perceive the cosmos is itself extraordinary. The size of the universe is not only a scientific concept. It is a perspective that reshapes how we see our place in existence. We are small, but we are aware. And that awareness bridges the gap between the human scale and the cosmic scale.